Okay, this is your final supplementary video. This is chapter 21, Solid and Hazardous Waste. It's a fairly short chapter, and there's not a whole lot of slides to go with it. There's material that I just don't cover that's covered in the chapter, and this is not a section that I emphasize, but I do want to start off talking about some basic definitions. So solid waste, incidentally, I think I mentioned this on the slides, the United States produces more waste per capita in general than any other industrialized nation. That means per person. Um, so we are generating a lot of waste in this country, and understand something about that waste would help us to basically kind of start to live a little bit more sustainably and reduce that waste. So your book defines a solid waste, as your chapter defines a solid waste as something that has to be solid. It says any unwanted or discarded material we produce that is not a liquid or gas. That's incorrect. Okay, as far as this country goes, EPA defines a solid waste as any waste basically that is not hazardous. So that includes solids, liquids, and gases. I mean, just think about it. You throw sometimes liquids into your trash can. That is solid waste, right? If you have maybe used cooking oil that you want to put down your sink for fear of clogging it, you put it inside of a bottle and you throw it into your trash. If you have leftover liquid materials that have gone bad, sometimes you can pour them down the sink, but if it's something hazardous, it shouldn't go in your trash can at all. But the problem is some people do put like old pesticides and used oil. Those are actually hazardous waste. But most of the waste we generate in terms of our houses is solid. But in terms of EPA, this can be a solid, a liquid, or a gas. And that's just something important to realize. So the way EPA would find it, basically any garbage or refuse. It could be sludge from wastewater treatment plants, water supply treatment plants, or air pollution control facilities, and other discarded materials resulting from industrial, commercial, mining, agricultural operations, and community activities. Basically, everything we do leaves behind some kind of waste. Um, so it's important that you realize that it's not limited to a solid. Now, what makes it a hazardous waste? In general, what we're talking about here is something that is toxic to humans or the environment. The EPA will have certain criteria, and everybody treats this. Different countries do different things. As far as our country goes, we have certain criteria in which we designate something a hazardous waste. So it's going to have to do with its degree of toxicity and a degree of its potential to harm the environment or humans. Okay. So really it comes down to its toxicity. That's going to define a hazardous waste. Um, some other things to think about when we think about the waste that you generate and your garbage, that is a solid waste. That's what we call our municipal waste, okay, coming from municipalities. That represents a small amount of the total waste. It's still important, but it's only a small percentage, something like 2% of all the solid waste we generate. Most of it comes from mining operations. So if you're going to go mine for some metals that you need, that creates a lot of the leftover tailings from the ore, the rock that was removed. That's a tremendous volume of material, quite frankly. And also gas and oil production produces a lot of waste also. On top of that, you have agriculture. Agriculture represents about 13% of all the solid waste generated in this country. If you take mining and oil together, that's about 75%. I think the mining is about 60%. Agricultural waste, people don't think about that, but you have a lot of crop waste. You have, corn stalks, stuff from pruning, animal waste, manure and carcasses, food processing. And to think about this, only 20% of the corn is actually canned. The rest is waste. Okay, so agriculture does generate a lot of waste also. And then, of course, there's industrial waste. So your municipal solid waste is your garbage, but then you can have that industrial solid waste, which can be from mining and petroleum and any sort of factory operations. When we think about the waste you collect from your homes and from commercial businesses and restaurants and office buildings, that's all our municipal solid waste, which goes, we call garbage basically, right? And a good amount of that actually winds up going into landfills. And that's one of our options here for solid waste is landfills. And something like greater than 50% of all of our solid waste goes into landfills. Even some of that, the mining waste and stuff like that I've talked about, as long as it's not hazardous, it goes into landfills. When you look at what goes into a landfill, the majority of it, about a third of it, is paper and paperboard, which of course is recyclable. Something like 13% of it is like plastics, which is recyclable. Metals are like 9-10%, which is recyclable. A lot of the stuff, yard trimmings can be composted. A lot of the stuff that goes into landfills can be recycled, can be reused, and converted to something else. So we could seriously eliminate a lot of what goes into a landfill and have landfills for only very specialized types of disposal, stuff we can't reuse and recycle, and then would take up less land. It could probably decompose faster. We can keep it maybe more contained. So it's important to realize also that landfills are not just big dumps nowadays. The old ones were, but now they're created in such a way that they're much more state of the art. And you can look at a figure in your book. I think I mentioned it in one of the slides, but basically we cover it with soil every day. Obviously, you don't want hazardous materials going into your trash. The landfill tends to go anaerobic, which means there's no oxygen. And when there's no oxygen, things tend to break down anaerobically, which leads to production of methane. And we talked about methane, CH4. So that is a very potent greenhouse gas, remember. So most landfills don't collect the methane. So it's something we need to start doing a better job of if we're going to use use landfills. Ultimately, we'd think that landfills should be done away with. They are a pretty archaic way of dealing with waste. As of 1983 in this country, all landfills have liners, all have leachate collections. That means when it rains and leachate comes through there, we collect it, we treat it, and we also monitor for groundwater. This doesn't mean that they don't leak. Most liners do leak. EPA will tell you that. They get punctured by small animals, boring, organisms, stuff that's sharp and penetrates it, chemicals that break it down. So you will wind up with landfills ultimately leaking. That's all there is to it. Other than landfills, we have some other options. We can incinerate it. This is basically burning it. And you will see the waste to energy talked about. And that is we're going to burn it, but then we're going to harness it as energy. So basically you're using it as a fuel, which can be pretty worthwhile. Some countries use this a lot more than we do. There is some concerns with it, and that is air pollution. With landfills, it's mainly water pollution and methane production and use of land. With incineration, it's air pollution. So theoretically, we should be able to make really high-end incinerators, and we do this nowadays. There's still some air pollution issues, but we are capable of capturing a lot of that air, treating it, removing chemicals and stuff like that. And then you can get energy out of it. And it reduces your waste tremendously. I mean, something like 85%. So if you start out with a kilogram of waste, you're going to wind up with 0.85 kilograms removed. Pathogens are killed. There's no water pollution. Metals can be recovered. The big problem is you wind up with an ash and air pollution. And an ash may be hazardous depending on the waste. And last of all, the most ideal thing would be the 3 R's, of course, and that is to reduce, recycle, and reuse. One thing you can do is compost materials. So stuff like yard waste can be put into big piles and aerated and turned into a good agricultural soil amendment, right? People do this naturally. I have a compost pile in my backyard. This is a good way of doing things. Recycling materials, of course. There are some limitations to recycling. I asked you that in one of the quiz questions. Your book talks about it. Reusing things. And ultimately, the best way to do this, and we talk about this throughout the chapter, is this integrated waste management. And that is really from the get-go, the most important thing is to just eliminate stuff and reduce using it, period. That's the best choice. rather than treating it after it's produced or then storing it ultimately for long term, like a landfill. So that's the best approach. Now, hazardous waste, I want to make sure you understand this doesn't include radioactive waste. Radioactive waste is a totally different category and is treated completely different. It's not something your book deals with, and I'm going to talk about it. But I do want to make you aware of that. Um, so once again, this is just something that's going to be toxic, something that's not considered a solid waste is now considered a hazardous waste. And the same criteria we're going to use, I mean, the first priority will be basically to prevent it. We don't want to produce this stuff. If we produce it, then we want to try to treat it and make it less problematic. And if we can't do that, then we have to store it, and that's our last choice. And that's really what we want to kind of avoid is storing it. So ideally, let's try to get to that point where we actually are no longer producing this stuff. So as far as options, ultimately, first of all, the culprits here mainly are going to be chemical industries, petroleum, and metal related, and that's where a lot of where your mining comes from. Now, keep in mind, these companies are producing products that we use, so it's not appropriate to point your finger at them and say, "Oh, they're the problem." No, part of it is of course, that we purchase these products and we use these products. We would like these companies to be a little bit more accountable and to be a little bit more environmentally conscious in the process of um, obtaining these resources. And one thing we do a poor job is to factor into the cost of a product the damage that's done to the environment or the money and the energy that's going to be needed to restore the environment to its original condition or to clean up the mess that was there. That is not factored into the cost of the product. We simply degrade that capital and don't factor that into the total cost. We talked about that early on in the chapter early on in the semester about capital degradation. So those are the three main culprits. Ultimately, once again, produce less, if not convert to less or non-hazardous. Third option then would be long-term storage. So you want to produce less. You want to treat it if you do produce it, and ultimately you want to store it is your last option. Once you store it, well, you can use a landfill, but this is a special landfill, not the landfill where your garbage goes to. It's going to be called a secure landfill. So that's one option. This really will have, specialized containers and storage spaces underground. So it's not going to be just like a big hole in the ground with a liner. That's what your landfills are, big holes in the ground or heaps above the ground. They do have liners and collection, all that, but these are going to be more like a repository with actual drums with materials in them and stuff like that. Otherwise, the other stuff is similar. We typically have a double leachate collection system and double liners and things like that. But otherwise, general design is about the same. Another thing you can do is what's called deep well injection or underground injection. A lot of people don't realize that we even do this with hazardous waste. And something like 60% of all your hazardous waste is disposed of like this. Now, of course, this is only for liquids. And what you're simply doing is, if this is your ground here, you're simply injecting it deep underground. And if you will, it's going to be below any sort of water source. So this might be your aquifer here where you're tapping in to get water. But what you're going to have ultimately is this area here would be considered a impermeable layer, so that this here where you're injecting your waste is separate and can't get to the water. That's the idea with deep well injection. Problem with that is waste can travel like this along this line here and ultimately get into your water. Also, underground there's also cracks and fractures, and these can develop over time too with earthquakes and stuff like that. And you can see how ultimately a crack or fracture can ultimately lead you directly to a water source and get into your water. So it is something we do with a lot of our hazardous waste. A lot of people have problems with it. It's not a great long-term solution. While it might be stable for a couple hundred, even thousands of years, ultimately you could contaminate an entire aquifer if some of this hazardous waste got into it. Another thing we do is just above ground lagoons or ponds. In this case, we're just storing the materials in a lined facility above ground. And the idea is that ultimately the liquid evaporates. Some chemicals are going to get into the air, of course, but ultimately the idea is that some of that waste is just contained within that lagoon and slowly degrades over time and is maintained there. And you can keep adding to it because the rate of evaporation of the water keeps the level low enough. You can get those stuff volatilizing and stuff ultimately leaching through the liners and stuff like that. So it is a pretty archaic way of doing it, but it is something that we do. Um, so once again, the ideal option is to produce less rather than treating it afterwards. There are things you can do to treat it. You can chemically treat it. You can talk about this right here. You can chemically treat it. You could put it in the environment, have it kind of naturally broken down and degraded, and then it can be disposed of as a solid waste. So there are options here for treating it, and if you can do that, then you don't have to store it the same way. There is thermal treatment. There is some types of incineration that can be used, land treatments, all that kind of stuff can be done. But ultimately, if you want to produce less, one of the things we can do is what's called green chemistry. And this is a big area now. This is the idea that we're going to do things in our process of making materials, okay? In our process of recycling and reusing, we can produce less waste. We're going to make sure that the material that comes out as a waste is easily reused somewhere or recycled, or we're going to eliminate that waste altogether. So one thing we do in the process of making things, we can substitute chemicals. Something that green chemistry does. So say there's this toxic chemical we use to make a product. So for instance, we have, if you will, A plus B goes to C. This is the product we want. And in that process, we have to add something that's somewhat toxic as a catalyst or something that is the solvent that the reaction takes place in. This now has to be treated as a hazardous waste somehow. So if we can either reuse this over and over again, capture and reuse it, that eliminates it needing to be disposed of in the environment. But a better approach even is to actually substitute it. Replace it with something that's safe and that doesn't need to be treated as a hazardous waste. And one thing people are doing a lot, which is called supercritical carbon dioxide, all you have to know about that, it's kind of like carbon dioxide at a high temperature and pressure that acts like a liquid and a gas. We've done this now to extract caffeine from coffee. We've done this in the dry cleaning process. We've replaced chemicals that are potentially toxic and carcinogenic with carbon dioxide, which is harmless in terms of toxicity. Of course, it's a problem in terms of climate change. But if that CO2 is continually captured and reused over and over again, then we don't have that problem with climate change at all either. So green chemistry is a way we can tackle the problem right at the start of the manufacturing process. And that brings us to the end of the video. So in summary, what you should get from your reading, from this video, and from your slides and your worksheets is be able to define solid and hazardous wastes. So before you take your quiz, you should accomplish these types of things. Recognize the problems that occur with these solid wastes. Throughout your textbook, we have this integrated waste management idea. This is the idea of, these 3 priority steps and which one would be the most preferable and then which one would be the least preferable. Understand some issues about recycling, some of the limitations to it. What are the problems with waste energy? What is the advantages and disadvantages of all these things? What are advantages and disadvantages? Details about landfills, some of the things we do, with some of the characteristics of them. And this right here is basically our hazardous waste main options. There are other options chapter talks about. But these are the three main ones that I want you to be familiar with. Make sure you understand the differences between a secure landfill, which is for hazardous waste, and a regular sanitary landfill, which is for your garbage. And then you've got deep well injection and surface impoundments. And lastly, your book will talk about sustainability and some things we can do um, to deal with this waste and live more sustainably. And I think I asked you a question about that either on the worksheet or a quiz. With that, that completes the video.